Hi, this is a video to go through the revision for trigonometry. Alright, so we looked at in class is Pythagoras. So what we do is we have a look at the triangle we're looking at, and if we have no angles, if we are not looking for an angle, so there's no theta in here and there's no number written in here, that we've only got numbers, then we know we're looking for Pythagoras. Now the first thing that you need to remember or not remember, you can remember the formula, but also it is on your formula sheet. So you'll be given the formula on the formula sheet. Make sure you are familiar with where it is on the formula sheet, and then you can use it. So this is for the Pythagoras theorem, and that is for finding the long side, the hypotenuse, for finding a short side. It is whichever short side you like. The hypotenuse minus the other one, the other short side. So please understand where these formulas are on your formula sheet, or remember where they are. Okay, so let's have a look at this one. So we know that we are using Pythagoras. It is the long side. We're going to have c squared equals 6 squared plus 8 squared equals 36 plus 64. So c squared equals 100. C is equal to the square root of 100 equals 10. Now what it's asking me to do is it's asking me to find it correct to 2 decimal places. So again, I see I'm looking for C. Again, there's no angle. I've got no angle in here, no angle information in here. I'm using Pythagoras. So I am going to be using C squared equals 8.6 squared plus 7.4 squared. If I go to my calculator, I'm going to type that in as 1. I'm going to have 8.6 squared plus 7.4 squared equals, I'm going to get 128.72, and then I'm going to use the square root key on my calculator, and I'm going to find the square root of 128.72. And what I can simply do, since it's already in my memory, I can just push the square root and push the equals, and that will come up with 11.345. Now I have to do it to 2 decimal places, so I'm doing it to there. I look at the number after my stroke, see if it is higher or lower than 5. In this case it is higher than 5, so I'm going to come up to 11.35. Alright, let's have a look one more. It says find the length of the hypotenuse in these triangles, leaving your answer in exact value. So an exact value is fine. Over here, this 10 was an exact value, so I was able to write down the square root of 100. Over here, this thing here is not an exact value. So unless my answer is actually happens to be the square of a number, I'm going to have to leave it as a surd. That means I am going to leave it in this form. Alright, so I'm finding the long one. C squared is equal to 8 squared plus 17 squared equals 353. So what I'm going to do is I am going to see whether I can find a square root of that by putting it into my calculator. It comes up with a whole heap of numbers. So I'm going to leave it as C equals the square root of 353. That is my answer. Do not find what the value is. All right, so now when we look at these ones, finally, again, there's no angle. So we're looking for the short side. We're trying to find B. In this case, we are finding a short side, so it's B squared equals the long side squared minus the short side squared is equal to 75. B equals the square root of 75. I'm doing it to 2 decimal places, so square root of 75 is equal to 8.660. So that is going to be 8.66. All right, I'm not going to do the other 2. I will leave you to do those. All right, so let's have a look at now. That's Pythagoras. Let's have a look at SOH CAH TOA, which is sine equals opposite on hypotenuse, cos equals adjacent on hypotenuse, TOA, tan equals opposite on adjacent. Now these are my steps which I am going to follow for each and every one. So my first one here, I'm looking to find theta. It says label the triangle. There's my angle. Whether it's theta or it's got a number, that's my angle. So that's my opposite. There's my right angle. That's a H, that's an A. So I can see I've labelled it. So step one's done. Step two, choose a ratio. I've nothing next to the O. I've got A and H. A and H up here is CAH. So I'm going to write it out. Cos theta equals adjacent on H. And I'm going to substitute in. So I haven't got a value for theta. I have got a value for A. It is 19 on 26. Now I'm trying to find theta. I can't, this is cos theta. I've got to get this cos to the other side. So I take it to the other side. It is not going to be the same operation. It's going to be the inverse. And now I'm looking for cos minus 1 of 19 on 26. So if I look at my calculator down here, to get to cos minus 1, we are going to use second function button. And then we're going to use whichever one we need to use. And in this case, it is cos. So I'm going to use second function cos. And that is going to, on my calculator, it will actually come up as cos minus 1. I'll be able to read cos minus 1. So doing that, I'm going to go second function cos. And then I'm going to use brackets to put mine in. You can either use brackets or as fraction. 19 divided by 26. Close my bracket, equals 43.04. Now it's asking me to find it to the nearest degree. So that is simply 43 degrees. All right. Now the next ones, you're just going to do them all the same. I'm going to do C. I'm going to look at it. I'm going to label it. All right, sorry. So I'll label it. I've got an O. I've got a H here, and I've got an A. So when I'm looking at this, if I write it out, I haven't got a number next to the H, so it's going to be TOA. I've got the O and the A. Tan theta is equal to O on A. I'm going to substitute in step 4. Tan theta equals 12 on 14. Theta equals tan minus 1. 12 on 14. Again, if I'm trying to find that in my calculator, to get tan minus 1, I need second function. And then that will give me this thing here, tan minus 1. So I push the tan button. It will come up on my calculator. I should be able to read it, tan minus 1, if I've read the right directions, if I put in the right, push the right buttons. So doing that, again, what I'm going to do is I am going to push second function, tan, use my bracket and go 12 divided by 14, close my bracket, go equals, and get 40.6. Now to the nearest degree, I'm going to go up. It's going to be 41 degrees. Okay, so this is the first type of problem we use for SOH CAH TOA when we're finding the angle. If we're finding the angle, then we're using this inverse relationship. We just go straight across, and we should be pretty straightforward to that in our calculator. Now, our second type of problem we're going to get is when we work out and substitute in, the number we're looking for is on the top. And that's the case, we're going to multiply by the angle ratio. So again, when I label, I've got O, I have got H, I have got A. I've got A and H, so I'm after CAH. Cos theta equals A on H, I substitute in. Cos 42 equals, value of A is X, and my H is 8. Now the number I'm trying to find, the X, is on top. So if it's on top, I'm not going to muck it around. I'm simply going to write x, that's what I'm looking for. I know I'm multiplying by the angle, the other number by the angle. I'm going to put that in my calculator. This time I'm not using second function. I've got 8 times. I'm just pushing the cos button, and then 42 equals 5.94. I'm going to come up here and see what it's asked me to do. It's found in 2 correct decimal places. Putting my slash in there, the 5 is bigger. Or it's, I need to round up, 5.95. I am done. Doing one more to demonstrate. Once again, I am labelling. I have got an opposite. I have got a H here. I've got an adjacent. I'm using O and H. That's SOH. Sine theta equals O on H. Substituting in the values I've got. Sine 23 is equal to O on H. So sine 23 is equal to, what have I done? O is x on 1. Okay. So that is simply giving me x equals 1 times sine 23. Sine 23 equals 0.390. Got to find it correct to decimal places. The 0, I'm just going to leave it as it is, 0.39. Okay, so whenever we set it up and we find what we're looking to do is on top, we simply multiply them together. Now what we're going to do is we're going to look at our third type of problem. Now this is the type of problem when we get to our ratio, the number we're looking for is on the bottom. And when we're going to do that, we're going to divide by the angle ratio. So what we're going to do here is we are going to, that didn't work very well. What we're going to do here is we're going to look at these problems. Once again, the first thing to do is to label them. O, H, A. I look at it, I've got an O and a H, my 9's next to the O. I'm looking for SOH because I've got O and H. I'm on sine theta equals O on H. Now I'm substituting in sine 42 equals 9 on X. Now what I recognise is I'm trying to find X that's on the bottom. My rule says divide. So X equals 9 on divided by sine 42, the same as 9. I'm just going to put that into my calculator. 9 divided by sine 42 equals 13.450. Once again, I'm trying to find it to 2 decimal places. 13.45. If I do this one, I'll label it again. O, H, A. I've got A and H. I've got CAH. Cos theta equals A on H. Cos 39 equals 45 on X. I see my X is on the bottom. I'm not going to muck around with a whole heap of manipulation. I'm just writing it out the way I know it is. If it's on the bottom, I'm dividing. 45 divided by cos 39 equals 57.904. Once again, 4 is less than 5. I'm ending up with 57.90. All right, now the last thing that we have done and looked at is angles of elevation and depression. Now these problems, you're going to set yourself up and it's just going to be the same as above. What we need to know is this thing in here is our angle of elevation. This thing up here is our angle of depression. They are equal. They are the same. So what that means is that if somebody's setting you up with a problem for the angle of depression, you can simply put that same angle down here if it helps you out with your triangle. So here we have it. We have it from a pedestrian overpass. Chris spots a landmark at an angle of depression of 32 degrees. How far away to the nearest metre is a landmark from the base of the 24 metre overpass. Now this has given us a side up the top, but what he is standing up here on the top, the little fella. He wants to know how far we are from the landmark to the base of the 24 metre overpass. That is the base of the 24 metre overpass. What we can do is we recognise that this is our 32 degrees. This is our height that he is at 24. We need to find how far away he is here at X. So we set it up, if we're doing that, this is our opposite. This is our hypotenuse, and this thing here is our adjacent. We have got O and A, we have got TOA. So we've got tan theta equals O on A. So we have, when we substitute in, tan 32 is equal to 24 on X. Now, in this case, X is on the bottom. If X is on the bottom, we are dividing. So we have got X equals 24 on tan 32. And when I throw it in there, I'm going to get 24 divided by tan 32 equals 38.4. And it's asked me for the nearest metre, so that is 38 metres. Finally, you might have a problem, which is a word problem where you have to substitute in. So David's in a lookout tower. He's up here in the air. If you want to draw his little tower, he spots a bushfire at an angle of depression of 25 degrees. So we've got our 25 in here. If the lookout tower is 42 metres high, how far away to the nearest metre is the bushfire from the base of the tower? So we're after this again, we're after X. Okay, this time around, once again, we're going to put our 25 down here because they are equal. Then we're going to set it up, so this is our opposite, this is our adjacent, this is our hypotenuse. We're finding TOA, O and H. We've got tan 25 is equal to 42 on X. We're using it's on the bottom, we're going to divide. X equals 42 on tan 25 equals 42 divided by tan 25 is equal to 90.0. Again, it's asked me to the nearest metre, so I'm going to put 90 metres. Okay, this is the end of this video.